Hello friends. In this lecture, we'll discuss about evaluation of the integral. Okay, so we have identified two types. One is between 0 to infinity e to the power of minus at t f of t dt, and the second one integration between 0 to infinity e to the power of minus at f of t divided by t dt. So in these two types of integral, they haven't mentioned anything about the Laplace transform, but we will see how the Laplace transform can be applicable to solve the problems which comes under any one of these form. Okay, so for that, so we can identify some working rule. So here the first case, to find integration between 0 to infinity e to the power of minus at, and here this expression we can write in bracket, that is t f of t dt. So if you look at here t f of t, so we can directly talk about the Laplace transform of t f of t, which is clearly case of multiplication by t. So now first we will identify that t f of t, then we first find the Laplace transform of t f of t, and let us assume that that is f of s. Now Laplace of t f of t is f of s. After this, how do we proceed? So we can make use of the basic definition of Laplace transform. Suppose if you consider f of t as a real valued function, then accordingly, by definition of Laplace transform, for f of t being a real valued function, we can have integration between 0 to infinity e to the power of minus st f of t dt. Okay, now if I compare Laplace of t dot f of t as Laplace of generalized f of t, then we can make use of this particular definition for this form also. Okay, so here we obtain Laplace of t times f of t, that is equal to f of s, and by using the definition, by using this above definition, it is integration between 0 to infinity e to the power of minus st, and this is our f of t, that is t times of f of t dt, which is equal to f of s. Now again, if you look at the standard form, we are interested in integration between 0 to infinity e to the power of minus at, of course t f of t, but here we have reached at the point integration between 0 to infinity e to the power of minus st. That means the coefficient of t is s, of course along with the negative sign, but we are interested this coefficient of t to be a, and that is possible just by substitution of by putting s equal to a. Okay, so that is 0 to infinity e to the power of minus at t times f of t dt, that is equal to f of a. So that means wherever s is there on both LHS and RHS, straightway we are replacing it by a. Okay, the same concept we can even apply for the second case. Integration between 0 to infinity e to the power of minus at f of t divided by t dt. So initially, if you just focus on f of t divided by t and find the Laplace transform of this particular function, it will give Laplace transform of f of t equal to f of s. Then again, by using the definition of Laplace transform, we know that if f of t happens to be a real valued function, then Laplace of f of t equal to integration between 0 to infinity e to the power of minus st f of t, the same f of t been replaced here, dt, that is equal to f of s. And if you want to use this particular definition for this form, Laplace of f of t divided by t, that is equal to f of s, we can have, okay, L of f of t divided by t, that is equal to f of s, and of course by using the definition, we have integration between 0 to infinity e to the power of minus st, the same f of t we can retain here, that is f of t divided by t. So this f of t divided by t we can consider as a generalized f of t, generalized real valued function, that is equal to f of s. But as I told you, we are interested in e to the power of minus at, that means the coefficient of t happens to be a, but here we have the coefficient of t as a s. So that is possible just by replacing s to a. So put s equal to a on both LHS as well as RHS, and finally we obtain the result as 0 to infinity e to the power of minus at f of t divided by t dt, that is equal to f of a, by replacing s equal to a. Now let's see how the problems works on this particular two types. Now, let's see the first problem. The question is evaluate integration between 0 to infinity e to the power of minus 3t t sine of t dt. As you can observe here, Laplace transformation has not been mentioned, but still the Laplace transform plays a very important role for solving this type of integrals. So when we come across under the integral sign the product of three functions, and how do we start, whether from the e to the power of minus 3t or from sine of t. So we always prefer the direction from extreme right towards the left, and accordingly our choice is, the first choice would be sine of t. So here I'll take f of t as a sine of t. Let f of t as a sine of t. Then after f of t, the next step would be finding the Laplace transform. Then we can have Laplace of f of t, that is Laplace of sine of t, and Laplace of sine of t, which is 1 divided by s square plus 1, and that is f of s. Then after sine of t, we have the next choice is t. So together sine of t with t, it resembles like multiplication by t. So we can introduce here. Now Laplace of t sine of t, we can write directly minus 1 raised to 1 d by ds of f of s. Since n equal to 1, it has to be only minus 1 raised to 1 and differentiate only once, that is f of s. f of s is 1 divided by s square plus 1. So we can substitute here, that is minus 1 d by ds of 1 divided by s square plus 1. So derivative is obviously minus 1 outside minus 1 divided by s square plus 1 whole square, and the derivative of s square, that is 2s. On simplification we obtain 2s divided by s square plus 1 the whole square, and that is the Laplace transform of t times sine of t. And just for our understanding, we may write phi of s instead of f of s, a general notation. Now we have reached up to this, let us call this as equation number 1. So Laplace transform of t sine of t, that is 2s divided by s square plus 1 the whole square. But the question is, we need to evaluate this integral 0 to infinity e to the power of minus 3t t sine of t. So up to t, by using t sine of t, we found the Laplace transform. So from there, okay, that is after equation number 1, just to achieve that particular form, we apply the definition of Laplace transform. By using definition of Laplace transform, we obtain, what is that, integration between 0 to infinity e to the power of minus st, and this t sine of t is my f of t. The same t sine of t I have mentioned here, that is 0 to infinity e raised to minus st t sine of t dt, that is equal to the right hand side 2s divided by s square plus 1 whole square. That will remain as usual. But are we interested in e to the power of minus st? No. In the given problem, it was e to the power of minus 3t. Just to achieve e to the power of minus 3t, straight away we can replace s by 3 on both the side, LHS as well as RHS. That is, so here, as we reach up to this particular point, 0 to infinity e raised to minus st t sine of t dt, 2s divided by s square plus 1 the whole square. And just to make s as a 3, we replace s equal to 3 on both the side. So we obtain integration between 0 to infinity e to the power of minus 3t t sine of t dt, and on the right hand side wherever s is there, that can be replaced by 3. 2 into 3, that is s square as a 3 square plus 1 the whole square. And finally we may have 6 divided by 100 as 3 divided by 50. Okay, so let's have one more problem which is based on that evaluation whenever the division of t comes into the picture. So here we have show that integration between 0 to infinity sine of at divided by t dt, that is equal to pi by 2. So in the initial stage, if you simply concentrate on sine at divided by t, it resembles like f of t divided by t, which we have used in the division by t. So we can write sine at divided by t, that is equal to f of t divided by t, and very easily we can identify f of t, that is sine of at. So just write f of t equal to sine of at, and after getting f of t, the next step is finding the Laplace transform of f of t, which is Laplace of sine of at. And the Laplace of sine of at, we know that a divided by s square plus a square, and that is f of s. And since we have sine at divided by t, so we can apply the division by t form, and accordingly that is Laplace of sine at divided by t, which is equal to integration between s to infinity f of s ds, and a divided by s square plus a square is our f of s. So we can replace that f of s by a divided by s square plus a square, rest will remain same. Now this a can be taken outside, that is a integration between s to infinity 1 divided by s square plus a square ds, and straightway we can have the integration, that is a 1 by a tan inverse of s by a, integration between that is limits between s to infinity, that is a will get cancelled, and tan inverse of s divided by a between s to infinity. So once we replace s by infinity and then s by s only. So now we have Laplace of sine of at divided by t. That is sine of at divided by t is tan inverse of s by a between s to infinity. Again tan inverse of infinity minus tan inverse of s, that is pi by 2. Tan inverse of infinity is pi by 2 minus tan inverse of s divided by a. And this is Laplace of sine of at divided by t is cot inverse of s divided by a. Now from this we can apply because it is Laplace of sine at divided by t, straightway we can apply the definition of Laplace transform. So by using the definition of Laplace transform, we obtain on the left hand side integration between 0 to infinity e to the power of minus st sine at divided by t dt, that is equal to cot inverse of s by a. And since in the question it was just 0 to infinity sine at divided by t dt, on the right hand side we have the value as of pi by 2, but e to the power of minus st was not there in the question. So that means we don't need e to the power of minus st term in the final answer. So that is possible by substitution of s equal to 0. If I put s equal to 0, it becomes e to the power of minus 0, and that is obviously 1. So by substitution of s equal to 0, we obtain 0 to infinity sine at divided by t dt, and the right hand side cot inverse of s divided by a, that is cot inverse of 0 by putting s equal to 0, and cot inverse of 0 is pi by 2. So therefore the final answer is integration between 0 to infinity sine at divided by t dt, that is equal to pi divided by 2. So with this we have seen the two problems, one with the help of multiplication and one with the help of division. Okay. So for more problems you may refer to the link provided in the description, and for any doubt or query please comment, and don't forget to subscribe, share and like the video. Thank you.